So, hello everybody. I am Christiane Hübner, the Information Officer of SIOS, and I would like to welcome you to this event on behalf of SIOS, both the participants of the Polar Night Week, the annual meeting of the SIOS community, welcome back, and everyone joining us via the live stream on YouTube. I am especially pleased to welcome the art community. But let me first introduce you to SIOS, the Svalbard Integrated Arctic Earth Observing System, who's hosting the event. SIOS is an international partnership of research institutions studying the environment and climate in and around Svalbard. We currently have 29 member institutions from 10 nations. The main aim of SIOS is to develop an efficient observing system of the Earth system and to enable researchers to investigate the fundamental questions of environmental change we observe. We share technology experience while working to reduce the environment. We share technology and experience while working to reduce the environmental footprint of science. Every January, we hold our annual meeting of the SIOS community, the Polar Night Week. Among other activities, it is a tradition to release the newest issue of our annual report on the state of environmental science in Svalbard, the SESS-REPORT. This year's release of the SESS-REPORT 2025 is a cooperation between SIOS, Arctica, and the Arctic Circle, which are two art residences active in Longyearbyen and Svalbard. Together, we have developed a program in which science talks will be accompanied by videos from a local performance artist. We will conclude with a conversation exploring the exchange between these two distinct languages, science and art. And I would like to hand over to Sarah Gerards now from the Arctic Circle, who will say some words about the artist.
Yes, thank you, Christiane. Sarah here in Longyearbyen. And over the past few months, we have been working on bringing together art and science that have been created in similar environments. And we invited the artist Stein Henningsen to present his work here. And Stein actually has a background in engineering and international marketing, but he has been working with performance art and visual art for the past 2 decades. And he often works with live performance on international performance festivals, but he also works with performances that are documented by video, especially when they are made here. And in that way, he can reach far beyond the places where they are created, which are here, so often quite remote. He himself, he refers to his work as live and poetic images that expose the conflict between what we know and what we fail to act upon. So looking at his work, you can, on different levels, he often deals with the urge to self-destruct, both personal but also larger. And he has been witnessing the rapid transformations here since growing up here. And by working in the Arctic and creating works in the Arctic and presenting them again and again, he presents the Arctic not as this like distant idea, but more as a lived reality. And I see his works very much as a visual invitation to engage. And here you will see shortened versions of the different videos that have been made. And all these works have been created over the roughly past 5 years. So they are not directly made in answer to the chapters, but we have been connecting them to the different chapters that will be presented very soon. And yes, then I would like to hand over the word to Clara Keuler, who is part of the editorial board of this year's SESS-REPORT. Thank you.
Thank you. Hi everyone. I'm Clara. I'm the early career member on the editorial board, as Lara just said. So the SESS-REPORT. The SESS-REPORT is published annually since 2019 by now, and it's an important source of information about the state and the of the environmental science in and around Svalbard. And it consists of interdisciplinary chapters covering different disciplines of earth science, and the chapters also include open questions and recommendations for the future, and altogether with the aim to improve and to develop the observing system based on the latest research findings and to make research data available. But not only that, the SESS-REPORT also comes with a general summary for every chapter to convey the knowledge to stakeholders and to the public. And with this structure consisting of the summary, the scientific course, and the recommendations, the report seeks to ensure synergy between research and societal needs in Svalbard. The SESS Report 25 consists of 4 update chapters. So update chapters means that the chapters add new research finding and new collect data to already previously published chapters. And a reason for focusing on the updates are the recommendations. So in the last 7 years, there were 282 recommendations collected from all the different reports. And the updates now gives the chance to consolidate and to refine the existing recommendations. And it is also an opportunity to review how previous recommendations may have been already implemented or maybe have changed. And it's a nice way to see that the report is indeed contributing to improving Svalbard's research structure. But for now, let's see what the authors of this year's chapters can tell you about their work. And we start with the first chapter presented here by Alexandra Smirak-Sikora from NTNU and Simon Schad from UNIS and University of Bremen. And they will tell you something about the geology of Svalbard, evidence of climate change through hundreds of millions of years. Thank you.
Thank you, Clara. Can you hear me? I hope you can. So I would like to present our second report. Presented by bedrock geologists. This year, we would like to focus on climate, deep time climate data, and I would like to first explain you what do we mean by deep time. So if you look at the plot on your left-hand side, you see a colored bar with millions of years next to. So that's the age bar. We have 23 million years down to 539 million years. This plot represents the history of Svalbard. When we, in the horizontal scale, have equator, and towards right, we have a modern position of Svalbard 80 degrees north. So the plot between two spheres shows the path that Svalbard made to reach here. And it's striking to say that Svalbard is in the Arctic since last 100 million years, but earlier was not. So earlier it started being placed close to the equator and then slowly drifted to the north. And while it was doing that, we have 2 reconstructions. Lower, it's the reconstruction for about 400 million years ago, where we see different plates where they place, and yellow star shows position of Svalbard, close to the equator. And the upper sphere shows modern, 50 million years ago position, also the star very close to the North Pole. But this road from equator to the north was through different climate zones. So naturally, Svalbard was in the tropical climate, moving slowly northwards towards more colder climates, all the way up to the polar climate. But we can't forget the fact that climate has changed a lot since during the past 100 millions of years. And then we look at the big plot on the right-hand side, when we see in plot A, 800 million of years, and paleo latitudes are now in vertical scale. And the blue colors are marking the position of all different ice ages that we had before. And I would like to just point that Cryogenian, around 700 to 650 million years ago, we have had something which was called to snowball Earth. So entire planet was frozen. And following, we have a lot of different glaciations. But if we move to plot B, when we see this curve is trying to reconstruct global on the planet for the past 540 million years. And it's based on one specific isotope. It's called oxygen-18 isotope, which is preserved in the shells of the organisms that were living at those different timelines. We also see the extension of different glaciations here in blue, and the brown little dots are actually the large igneous provinces. These are the elements in geology when a lot of volcanic activity will produce a lot of gases and also mercury that we will see in the geological record. And those huge, large igneous provinces, huge volcanic activities really change the climate and are very often associated with mass extinctions. And finally, I would like to point to the most important part of this graph, the C part. When we see the colors in the bar, blue and brown and red, this is actually the same timeline, 500 million years, but it shows how much of that is preserved in Svalbard. And we have to be really mindful that if we want to discuss global temperatures, even for today, modern world, we need to have data from all the places, not just from one location. One location will be not representative enough. So that's why its position of Svalbard and data that we have here are very crucial to help us understand not the path that Svalbard has made from equator all the way up to the north, but also how the global climate has changed from the past millions of years. Now I would like to hand over to Simon, who will be talking about the data.
Yes, thank you. And Alex already kindly introduced the nice stratigraphic rock record of Svalbard and how much data there is. And many scientists have already measured an extensive record of such paleoclimate proxies like these 13 carbon, 18 oxygen or mercury proxies. And the studies mostly focus on specific time intervals. That's very valuable. However, the raw data itself is then mostly hidden in supplementary files, just in data tables. And we now went ahead and gathered all this data of openly available publications and curated it in 4 different data collections, namely for this 13 carbon isotope, 18 oxygen, mercury, and also pyrolysis data. And we uploaded these data packages to the NIRD Research Data Archive, and you can find them either there or you can find them in our update chapter. And with our contribution here, we want to make this data more accessible and also enhance its reusability in the future. Thank you.
Thank you very much. Now we come to our second chapter presented by Lindis Bioland from NIPR and talking about how changes in Earth's magnetic field affect the aurora.
Thank you. If you have spent some time in Svalbard during the polar night, you've likely been captivated by the aurora dancing across the sky. Svalbard is one of the best places in the world to study the aurora, but why is that? Well, the Earth acts like a giant magnet, and particles from space follow the Earth's magnetic field towards its geomagnetic poles. There they collide with the Earth's atmosphere, and light is emitted, creating ovals of aurora around the poles. The Earth's northern geomagnetic pole is currently located in Ellesmere Island in northern Canada, and Svalbard's position relative to this is so that, given the right conditions, it's possible to observe aurora from Svalbard at any time of day. The aurora ovals are, however, very dynamic. On short time scales, disturbances in the Earth's magnetic field, known as geomagnetic storms and substorms, can expand the auroral oval and shift its position. An example of this could be seen just last week when a major geomagnetic storm caused aurora to be visible across large parts of Europe. The magnetic field is also changing on the long term. the poles are moving and the magnetic field itself is weakening. Our original pole motion project set out to investigate what happens to the auroral oval due to these long-term changes. By analyzing satellite data from above Svalbard, we found that the auroral oval is slowly moving southwards due to these changes. This year, in our update, we have looked at magnetic field measurements from 4 stations in Hornsund, Hopen, Longyearbyen, and Ny-Ålesund, as you can see on the map, and confirmed that there are consistent magnetic field changes across the Svalbard archipelago. Further, we looked at data from Iska Svalbard radar, as you can see in the picture, and tried to develop an automated method to detect aurora from the Iska Svalbard data. And our results, they align with the satellite results. The auroral oval is shifting its position. Luckily, you do not need to worry. This shift is small and aurora will not disappear from Svalbard anytime soon. However, the long-term changes in the magnetic field are important for navigation systems relying on compasses. For example, runway designations at airports periodically have to be updated because the magnetic north they align with has shifted. Understanding how the magnetic field changes is therefore important for long-term planning and operational safety. So the next time you watch the aurora, you can think of it as a visible reminder that there are invisible processes. The magnetic field is changing and interacting with space on both long and short timescales. And thanks to all the instrumentation we have on Svalbard, we are able to observe and monitor these changes. Thank you.
Thank you very much. Our next chapter will be presented by Lauriane Kellever from INAR, and she will talk about the particles in the air originating from biological processes.
Thank you very much for the introduction and giving me the chance to showcase our new or chapter update about Svalbard aerosol. It's actually mostly about trying to understand the sources of natural aerosol and their mechanism of formation. So aerosol are important for climate as they are directly impacting the climate either by absorbing or reflecting the solar radiation, or when they act as cloud condensation nuclei and therefore impact the formation of cloud and the cloud property. It's important to understand our aerosol forms and their sources, because in the Arctic we are facing a temperature that are warming up to 4 times faster than the rest of the planet, and therefore the Arctic environment is changing, and the source or the normal sources of aerosol will evolve as well in the changing Arctic. Up to 90% of aerosol particles come from this process of new particle formation, where actually gases are emitted in the atmosphere and they are able to stick together, nucleate, and grow to further sizes, hopefully reaching the size of cloud condensation nuclei. We have been measuring in Svalbard since 2017 at the Gruvebadet CNR observatory that you can actually see here in the picture in Nualesund. And thanks to our measurement and our partners' measurements, we've been able to gather long-term time series about those gases, also called condensable vapors, and their related or the corresponding aerosol size distribution, which would give the step after the nucleation. So our measurement has highlighted the fact that we have many different chemicals that are involved in the formation of new particles, such as sulfur-containing compounds, which have a more marine origin, or iodine-related compounds that are emitted from the, or mostly during the transition from winter to summer and vice versa. And as well as bases such as amine or ammonia that are emitted by the local fauna, and also, more surprisingly, from the vegetation. Maybe from the picture it's not very obvious, but during the summer season, even like small vegetation in the tundra, in the Arctic tundra, can emit VOCs that can further oxidize in the atmosphere and contribute to this loading of condensable vapors. Of course, as these compounds are linked to the environment, they have their own specificities also, with the very strong seasonality of the Arctic region. And all of these also impact the new particle formation frequency. Of course, now for us, it's all about understanding on how those molecule and sources are intertwined together to actually form particles. And even more important now, since the Arctic is rapidly changing, we also have to understand how those vapors will evolve with the changing climate. And we have now gathered all of this, or many information in this chapter that I invite you to read. Thank you.
Thank you. And our final chapter will be presented by Richard Hahn, director of the NTNU Icing Lab, and he will talk about uncrewed vehicles used in Svalbard science.
Yeah, thanks for that. So our chapter has a slightly different scope. We were mostly focusing not on scientific results, but on the tools that are used by scientists in different fields to obtain them. In particular, we're focusing on a new technology, or a relatively new technology, of uncrewed systems. And it's basically two systems that are seeing a lot more use in Svalbard over the last couple of years. And that's the use of uncrewed aerial vehicles or like flying drones, and uncrewed underwater or some sort of marine vehicles, so some sort of robots that can swim underwater or on the water surface. And we've been following kind of the use of these new tools for a couple of years, and seeing how the use has been changed and trying to help scientists to use these tools more efficiently in the future. So if you maybe click one more time, there'll be maybe some text appearing.
No.
Okay, well then there's no text. That's fine as well. So the main things that we found in the work that we've done now is essentially we found that it's getting more and more people and different fields of science in Svalbard that are using these uncrewed systems. So it's a real value that these robots can give to Svalbard. And as such, they're really important because they help us understand the environment in a new and better way. You get like the bird's eye view, you can get an underwater view. So there's a lot of examples of how this gives additional data to be used to understand processes such as climate change or melting of glaciers. To give one very concrete example, it's a project that I've been involved in. Just to give you an idea of what this means in practice, you can go to a glacier, you can study the glacier, you can see how does it change over time. But typically you only see what's above the waterline, maybe just what you see if you're there yourself, or you can use satellite images, but satellite images have a very bad resolution. Everything is very pixelated, it's difficult to see. But if you use this aerial and underwater drones, you can actually get like a very high resolution picture of a glacier. And then also have a new perspective to basically also see what's happening underwater, what's happening to the glacier front under the waterline, how does it affect calving processes, and so on. So it's just a concrete example. In the report also what we found is that there's new rules coming, or there's new rules that have been introduced that makes it actually more difficult for scientists to do this work. The rules were introduced to protect the environment, mostly to limit the impact of tourism, because tourists, of course, love to fly their drones as well. But we also see that this can potentially make our work a lot more difficult. So there's some recommendations included here of trying to engage with the rule makers to make sure that kind of scientists have the possibility to make exceptions to make their work, to still do their work. And the last bigger finding was that we are hoping to use bigger and more complex systems, both aerial systems and marine systems, in the future, but these systems are very expensive. And one of the biggest expenses is actually shipping the systems up to Svalbard. Just the pure price of sending this equipment safely up to the island and down again is very expensive. So one key recommendation is that we should, or SIOS should probably engage in fostering more sharing and dialogue between people who use this, and maybe facilitate for some common resources, maybe a big drone platform that can be used with different partners. So that's some ideas to that direction. Yeah.
Yes, thank you. So, merging science and art is a complicated endeavor as they live from very distinct languages. On the other hand, they address often the same issues. And that's why we challenged the authors of the chapters to send us their thoughts and questions to the videos. Their beautiful reflections made us realize that this exercise is maybe not that complicated after all. I would like now to invite Stein on the stage so he can respond to some of the reflections by the authors. Are you there, Stein?
Yeah. Hello, everyone.
Welcome.
Thank you.
So we start with the first chapter, and the first comment from the geology team to the connection with the video of that you call My World, where you are destroying a piece of ice that is carrying you. This could illustrate how the humans impact the climate. The team documents extreme climate changes that existed long before the human era. It can be seen how these changes accelerate with human activity.
Yes, I think that is what My World is about as well. This accelerating process of humans destroying the planet we see today. We are destroying the world, definitely like it is today. But not only in regard to the atmosphere, the CO2 and the ecosystem and that sort, but also global conflicts and global resources. So I'm trying to say that as a successful species, we are being pretty self-destructive. So that's
Yeah, and the team around Lindis, they study very slow shifts in the Earth's magnetic field that only become visible when you look across decades. Their question in relation to your video, The Red Drum, was, your performance involves a simple action repeated across a landscape. How important is duration and repetition to you when trying to make invisible processes felt or noticed?
That's a very hard thing to do, yeah. But in a video work, the viewer's attention is a short attention span, a lot shorter than in a live performance. So I need to make the audience have this feeling in 1 to 6 minutes. So that's important to have then. And I think simple actions, repeating them, that's a means of action here. So repetition of a simple movement. I feel is the best way to make these, to have this feeling of invisible process felt and noticed.
They also commented that as scientists, we rely heavily on conventions, reference frames, and predefined directions, and ask if in your work, symbols like an arrow still carry meaning once they are placed in an environment that does not acknowledge them.
Yeah, absolutely. Everything has a meaning, I think. But if you look at this video, the arrow is in an environment that acknowledge it, because the man rolling the drum is in an active environment, and I see the nature as a background here, and then a passive environment. So the active environment is actually acknowledging the white arrow, and then the arrow become really important, I think. So to me, this video is not about, the man is not following the rules, the order. So his understanding and knowledge is just put aside. As like the Peter Sloterdijk, the German philosopher, said, who wrote Critic of Cynical Reason, he would call this attitude enlightened and show that the mismatch between acknowledgement and action is tangible. And that you see in many of my works.
Yeah, the aerosol team connected to the video timeline. They note that the artwork draws power from what feels out of place. There's no vegetation in the Arctic scene, yet a piece of dead wood is deliberately introduced, carried and held by a man in a suit. It is brought into an environment that did not produce it. The question is related to our relationship with combustion and resource use. After burning forests far from the poles, are we now indirectly burning the Arctic as well?
I think that was a nice way of looking at it, but bringing the wood into the video. I didn't think of that. Bringing the wood, bring something into the wood, into the work. I was more trying to illustrate that if Earth's 4.5 billion years history were condensed into a 24-hour day, then modern humans would appear like the last 2-3 seconds before midnight. And despite this brief existence, we've made a massive destructive impact on the planet just in a fraction of a second. So and also putting this performance outside on a mountaintop of Svalbard with all this majestic nature, and that gives us a perspective and I think a visual understanding of the planet. That's how I thought when I was making the video.
They also say, we see that the heat is difficult to endure, and yet the wood continues to be held. This gesture feels symbolic of our collective human behavior, persisting in actions that are harmful even when the consequences become uncomfortable or undeniable, until there's nothing left to burn. The act of holding the wood raises the question, who ignites the fire and who sustains it?
I like this way of looking at my work, and I think they're great questions. And this is how I see my work as well. And I try to dive into the elements in my performances to illustrate my artwork with my whole body as a tool, rather than just being standing on the outside and looking in and observe and comment. So I think it's important to make the audience to see political artwork, want to see it rather than pushing them away in disgust. You should make them listen to repeated messages, people telling them. I think they should enjoy watching the artwork, have some time to reflect, and then want to join the cause or talk to other people and just like inspire people to action through art. Just like I think that is important when you work with art. That's why I do this.
Their final reflection is that this work ultimately confronts us with our share of responsibility in shaping the present and future condition of our planet, and with the possibility that awareness can still lead to care, restraint, and change.
Oh, yes, absolutely. Let's hope that happens. Or we have to believe that awareness can lead to action.
And this awareness can and should be raised by both science and art together.
Absolutely.
So thank you. With that, I would like to thank the scientists for their talks and thoughts. Thank you also to you, Stein, for sharing your art and reflections with us. I think we agree that science and art complement and enrich each other. Thank you for the collaboration, Sarah and Sally.
Oh, yeah, absolutely.
From the art residencies. It was very inspiring to work with you in this on this concept. And of course, thanks a lot to the editorial board of this year's SESS report, and especially to Clara Köhler, who presented here today. If you're interested in reading more about the environment in Svalbard, you can access and download the SESS report series via the QR code on the left side. You can also contribute to the SESS report 2026. The call is open and closes the 4th of February. And if you would like to learn more about the work of Stein Henningsen, there's a QR code on the right side. Thank you very much for joining us, and for the Polar Night Week participants, see you tomorrow at 9 o'clock. Thank you.